150 years ago, petroleum was not a way of life. It's been around so long that we can't imagine a world without it. And that applies obviously to energy, but of course to all the materials we make use of on a daily basis. 150 years from now, petroleum will not be the basis of modern life, not remotely. And it stands to reason in the next 50 years, products made via biologically sourced starting points will be the norm, not the exception.
Synthetic biology specifically, it's using a more quantitative way to achieve this goal that we can use biology to make our lives better.
Our ability to make many specific changes to the genome simultaneously is really changing the way we think about designing our experiments.
See which cell wins, or which cell grows faster, or lights up the brightest. And that really is a tool that, traditional engineering doesn't usually have access to.
What is Synberc? It's a way of thinking about how do we put it all together, because that's what engineers do.
The main aim is to make a lot of the biology that every biologist does more accessible.
We kind of feel like we're at the beginning of, what the semiconductor industry used to be like, or what the software industry used to be like. Designing more and becoming really more like engineers.
You're going to start to see a lot of real-world applications that synthetic biology enables.
So we did something that's really popular in synthetic biology lately, which is called parts mining. I took a light sensing pathway from blue-green algae. I engineered it to control gene expression in E. coli, to allow E. coli to do things that they've never been able to do before, allowing us to do things that we've never been able to do before with E. coli.
I've been developing heat-repressible RNA thermosensors. We're trying to cut off disease transmission of parasitic diseases. So it's a bacteria that has a genetic circuit inside of it. So once it leaves your body, it'll sense temperature, pH, and light, and then turn on a toxin. And so the production of that toxin will kill any parasite eggs that might be living.
As the field has progressed, we've really created a whole repertoire, a whole toolbox of different parts. The applications are very diverse, from health and medicine, manufacturing fuels and chemicals, all the way to next-gen applications that we would never have thought of when Synberc started.
So coming here and seeing what people were presenting on, getting a feel for how the community actually defines synthetic biology was extremely helpful.
To say hi to people I haven't seen in a while, to share what I'm up to get a sense of what the new state of the art is, if it's changed in the past 6 months.
The CRISPR-Cas system was mentioned many times today.
CRISPR.
It's very, very crispy.
Debating all the time. CRISPR, which is exciting, is it kind of a bubble or is it real? And we've just heard that people in the industry are actually using it.
In Synberc, the environment of academics and the companies coming together, I think, is very positive.
It doesn't go automatically from the lab to the shelves. And so having the interaction with people who are really in industry, we get to hear what their concerns are and try to work out solutions together.
One thing that Synberc does is it pulls in the next best generation of folks and gets them to this meeting. So I actually try to meet the younger people so I can get to know kind of who's coming down the pipe. That's good.
Synthetic biology really spans, at least on our campus, not only chemical engineering, but chemistry, bioengineering, molecular and cell biology, as well as microbial biology. I think that's one of the exciting things about being in a new field is you can start to form these collaborations with people that are really far outside of your area of expertise.